Okay, we've reached week 4 already. Now we get to low fidelity prototyping. This is quite a bit more practical than what we've been talking about so far. What I mean by that is, with this particular topic, you can't really get away from actually doing something. For all the other topics that we've done so far, we could just sit there endlessly talking about all sorts of different things. But let's be honest, it's kind of dumb to keep talking about prototyping and not actually prototype something. And actually, all the principles and the theories we've been talking about has come in no small part because of all the data and the information that we've gathered from all sorts of user testing, including live products and also prototyping. So I guess the idea with prototyping here is to try and maximize the amount of user testing information we can get. One key benefit of rapid prototyping and low fidelity prototypes is that it actually shortens the iterative design process. So this way we're able to identify fundamental problems in the interaction design like really early on. We don't want big problems to show up further down the line in production. That would be like building a 3-story house and then later on finding out that the first story is just really, really bad. How are you going to fix that then? You've installed some really nice finishes and high quality fixings and fancy schmancy tiles, and then you find out that you've got to knock the whole building over because you've done something bad in the early stages of construction, and we obviously don't want that. So in our field, the way this can happen is us making bad assumptions from the outset and not actually testing it. We can fall into this trap by simply looking at the existing body of theories and research and whatever principles that we follow, and then assuming that's actually enough. We have to remember that our field isn't actually that old, and we haven't discovered every single thing about human behavior just yet. So just think that let's be generous and say that interaction design in immersive environments has been around for 30 years. What we're competing against is 3.5 billion years of evolution in terms of all the different cognitive subsystems and motor systems that's developed over that period of time, which eventually resulted in what we have in our brain right now. Essentially, what I'm saying is we don't know enough about human behavior to design interactions in a vacuum. We eventually need to test it with real people. And I would say that's a pretty fundamental principle in human-centric design, because it's like, we're building this for humans, so let's test it on humans. To encapsulate this problem that we're facing, I'm going to remind you of the square hole girl. Let's just replay that video. I love that video.
This is a square. Can you guess which spot that goes in?
The square.
That's right. It goes in the square hole.
Yes. Okay.
And how about this rectangle? That one
Also the square.
that goes in there too.
Yeah.
Up next, we've got this thin rectangle.
The thin rectangle.
Can you guess where that goes?
The thin rectangle.
That's right. It goes in the square hole. And up next, a cylinder.
The circle.
I think that goes in
The circle.
the square hole. Now, we've also got this semicircle right here. Do you see a slot that would fit
The semicircle.
semicircle?
The semicircle.
That's right. It's the square hole. Okay. Up next, the triangle. We know what hole that goes
The
into,
triangle.
right?
Triangle.
That's right. The square hole. And up next, we have the arch.
The arch. The arch.
You guessed it.
The arch.
It goes in the square hole.
Hilarious. Haha. Beyond the comedic value of this video though, there are two things that we ought to notice. One, the person playing with the shapes and holes toy had complete agency as to what they wanted to do. They didn't have any interference from the girl. The second thing is the obvious distress that the girl is experiencing just from seeing someone using the toy in a way that they obviously didn't want them to. Now let's practice a little bit of empathy. So let's just pretend that we were the ones who designed the toy. We would feel the same discomfort that the girl was feeling in that video. I'm not saying the girl was the one who designed the toy, but it's a useful conceit. In our case, like, we would probably be feeling the same thing as that girl as we saw that misuse of the toy. But that's okay. This is an opportunity to improve the design. Maybe we can change the shape, so it's actually impossible to do the square-hole cheat like that. The point is, good design practice is actually subjecting our work, our design, to this kind of pressure, to this kind of rigor. This is a bit of a challenge to us creative people because we want our creations to work, we want our creations to succeed, but we have to be honest with ourselves. We can't just live in a fantasy land where we have wonderful designs on paper, but it doesn't actually work. So for our class, let's define what we mean by prototype. Now, it's pretty common practice, I've found, for people to refer to pretty much any part of a project that's not complete as a prototype. But for us, that's not enough. The key thing is that it needs to be independently interactable. It needs to be like that toy with the shapes. So yes, we need sketches, and yes, we need wireframes, but those things by themselves are not prototypes. And the main reason is our users can't play with sketches or wireframes. But they are useful to us as designers because we can use them to build our prototypes. And in the case of low fidelity prototypes, we can use our sketches directly in our prototypes. Like literally the sketches would be the graphics that we use for buttons and whatever else we're going to have. So in last week's live class, we've already talked about what a low fidelity prototype is. So I'm just recapping here a little bit for completeness sake and formality's sake, I guess. So what is a low fidelity prototype? It's something that's super rough. It has very little resemblance to the final experience, but it has the core of the experience, especially the core interactions. In the real serious games interviews, they sometimes refer to these core interactions as core mechanics. That's a terminology that's come from the game design world. You'll see these collisions a lot, especially considering the fact that the technology that we're using for a lot of these experiences actually comes from games. And actually, I'd say the most recent renaissance in immersive technology and virtual reality in particular was because of the launch of the Oculus Rift on Kickstarter. And we can really draw some connections there in terms of user or human-centric design, because the very first Rift that came out to the public actually wasn't a consumer version. It was what was termed as a dev kit. And the idea there was, well, first, I guess they wanted to send out the hardware to as many people as possible so they can get some real human user testing data back so they can then improve the hardware. And in fact, it went through several iterations before it finally settled on what was termed as the CV1 Oculus Rift. CV standing for consumer version. Now then you might ask, hey Matt, wasn't that Kickstarter the biggest grossing Kickstarter in history or something like that? Couldn't they have just used that money to do their own internal user testing of the hardware? And yeah, that's a really good point, smartass. But really, the bigger reason for having the early dev kit releases was to get people building software for it really, really early. Just by the fact that these headsets were dev kits, any software that you develop, by definition, could not have been anything other than a prototype. The main commercial reason for doing that was to have a critical mass of software ready for the actual launch for consumers to actually get. But from the immersive design perspective, that's super, super handy too, because that gives you a real chance to test your designs with real people, no matter how rough and janky your experience is at that stage. In some sense, you want the jank there because the jankiness makes it really easy to detect problems. In fact, many of the things that we talked about in the earlier weeks, especially safety things, were rediscovered during the testing with Oculus dev kit hardware. For example, the motion sickness problem was already well known within the academic community, but the game developers that were playing around with this new cool hardware had no clue until they gave it to people to test out. And in this period between 2012 all the way up to 2016, we get all the different locomotion solutions that we studied earlier in this term. We get snap rotation, we get teleportation, we get foveated rendering, and lots of other rendering optimizations. These things didn't come from a book handed down from, Bill Gates or Steve Jobs or whoever. They came about because these problems cropped up during user testing, and immersive designers came up with solutions. We need to be humble as immersive designers. We already know a lot, but we also need to realize that we don't know everything. That's why user testing is so important. It's so important that even low fidelity prototypes can be useful. So like I said earlier, it doesn't matter that the prototype is super rough. It can come in just about any form, and as we know, this includes non-digital forms. For assessment 1, certainly, we've talked about paper, we've talked about film. If you're rich enough, you could have actors. We'll talk a little bit more about this concept of Wizard of Oz, which is essentially a kind of an actor, but like not a visible actor. The main thing really is the low fidelity prototype is quick to make. It is quick to make because we want to test things as soon as possible. And what's implied in here as well is that we want to, at this stage, have a short or a really, really short iterative design cycle. So you test something, you find the problem, think of a solution, test that, find more problems, the cycle continues until you're satisfied that the key or the core interaction problem has been solved, and then you can go ahead and invest more time in the design. That is, you've made sure that your first floor is good, and now you can build your second floor and then possibly maybe add extra finishings. Please don't mind the construction metaphors. Let me know if it's not working for you. I'll think of something else. So anyway, let's have a look at some common types of prototypes. Low fidelity prototypes specifically. And we've talked extensively about paper prototypes in class, and you'll see a lot of that in the readings as well. As far as I can tell, these have really come to prominence because of the touchscreen revolution that was brought about by the iPhone. So a lot of interaction design texts borrow heavily from that. In fact, in our case in this course, we literally read William Buxton, and a lot of the stuff there is still relevant and useful. We just need to be careful not to be stuck in the 2D space. Remember, we're immersive designers, and we have all of 3D space and time to do our designs with. We're just not stuck on a tiny flat screen that we can touch. So that's why I'm always encouraging you to use immersive design affordances whenever we talk about paper prototyping. Take, for example, the surgery paper prototype. I specifically pointed out the grabbing and slicing interactions. Basically, something that we needed hand presence to do. Then we also have the diegetic two-dimensional interfaces that was actually within the 3D space. That is, you'll see flat, traditional two-dimensional text fields and text, but it's floating in 3D space, and you can see in the video that the user is interacting with it using their free hands moving around with the same hands that they used to grab the scalpel and slice up the virtual patient. Another type I've seen, which really is more appropriate for visualizations rather than actual prototypes, it actually really limits your interaction. The way I would describe it is animatic hybrid, basically. So this is where you would take pre-made assets. It might be digital renderings, it might be video clips, and basically mock up what it would look like to use your design. As far as I can see with this method, the most you can really do with this is have branching user choices with videos, kind of just like your choose your own adventure books or those quote-unquote interactive films. Off the top of my head, I can think of the Spy Kids 3D game on DVD. Although at that stage that was already a full product and not a prototype. But what I mean is the interaction is done just by using branching videos. The next type I've seen, which is my most preferred type, is just a rough digital. We'll talk a bit about the pros and cons of using either a non-digital or a digital prototype, but essentially this rough digital is just the latest build of the digital project that you've got. So it can be in any stage of development, from mega super rough with no polish whatsoever to maybe the alpha stage. But these stages are pretty arbitrary anyway, and you could argue that even released software are still prototypes because you still continuously release updates for them, so you can make the line a bit blurry, but we're playing with semantics now. So let's just say that a rough digital is basically from when you get the code working to alpha. And I think my mic just picked up a siren there, so hopefully I'm not getting arrested for speaking some kind of blasphemy here, which is of course a joke. Lol. Anyway, with all three types, we don't necessarily have to have all of the functionality implemented. Certainly in the paper prototype and the animatic hybrids, it's going to be super rare for all the functionality to be implemented. But how do we actually test the functionality if we don't have it implemented? Well, we can use people. The Wizard of Oz method is a very common thing to do, well, at least in experimental psychology, and it's the only way you can make a paper prototype work, unless you use mechatronics, that is robotic elements, but that's much easier to just use a digital prototype in that case. So anyway, I'm getting sidetracked. Wizard of Oz is essentially a practice where a human would fill in some of the functionality that's not implemented yet. So sometimes the user that's being tested isn't made aware that there is a hidden human making things work. In the case of paper prototypes, you can actually see the person moving the icons and the screens around. So like it's also possible to have someone be aware of the presence of the Wizard of Oz. For those that grew up in the West, the Wizard of Oz would be someone they would be familiar with. But for those that don't know the Wizard of Oz, it's a story, and I think it used to be a book and it turned into a film. And if you want to actually enjoy the story, this is spoiler alert warning, spoiler warning. The Wizard of Oz was just a man behind the curtain pulling levers to make a fire show. So the wizard looked really intimidating because of the show, but then you pull the curtain back, you just see some dude from the south, pressing things. Now, my direct experience of this is actually being the Wizard of Oz. So I remember being involved in one of these experiments where the participant would think that they're communicating with a robot. They would be in a room sitting across a NAO humanoid robot. So it's actually a real thing. But in fact, the NAO isn't acting by itself. I was listening to the user talk, and I was controlling the NAO. The key thing that you want to really avoid in that situation is the temptation to influence the user's actions. Because what you're doing as the Wizard of Oz is you're only merely facilitating the functionality of the design. If you were to make improvements on the fly, and you can because you're a human, you better be, one, absolutely aware that you're actually making the improvement on the fly, and two, write it down so you remember that you actually made the improvement on the fly and it wasn't part of your original design in the first place. You don't want to be fooling yourself into thinking that you're design was perfect because it worked in the test, but in fact, the Wizard of Oz was actually the one who improved it, not your design. To give a bit more of a concrete example, let's go back to Square Hole Girl. So let's just pretend that Square Hole Girl was the designer of the shape toy, and she was giving it to someone else to test it out. Now, instead of just reacting in dismay by the dude putting everything in the square hole, she might have just blocked the square hole. And that's perfectly fine. Maybe that's a functionality that hasn't been implemented yet. But if that wasn't part of the original design, the best thing to do is just keep letting it fail and then write it down. That way you're not interfering with the testing process and you're actually getting valid data, which you can then use to fix your design. And once that's done, run the test again with the new functionality and then see what else fails. Now, if you really can't help yourself, you need to make sure to note that you've made that modification. So in the Square Hole Girl example, let's just say that blocking the square hole wasn't actually part of the original design, and that was just something that she decided to implement there and there. Then after the test, she needs to write down the fact that she added that feature live, and that's why the interactions were succeeding. Like, that is, only the square shape was going through the square hole instead of everything else. Because if she didn't do that, we're still stuck with the old design that has that problem with the interaction. Now, the Square Hole Girl example is pretty overt, and it's really easy to spot that intervention, even if it was done live. But sometimes you get more subtle things, and the temptation to actually push the user to the right direction or the direction that you want them to go is really strong. So if you're the Wizard of Oz, or if you're trying to get someone to be the Wizard of Oz, make absolutely sure that the Wizard of Oz keeps to the rules. Otherwise, your testing is not going to be valid at all. And you'll be lying to yourself that the first floor of your house is being built right. You end up building on top of it with a second and third floor, and then the whole thing collapses, and then you're like, why? And then it costs you a ton of money, and then you got to start all over again. So, be honest with your testing. And now we get to the most contentious slide, and this is a debate that I have with Teresa continuously. But I think it's good to just set out the problems here. So, should we go analog or digital? If we're being pragmatic, we should just choose whichever one is quicker for us, because that's the whole point of rapid prototyping, and low fidelity prototypes are really good at that. But let's set out the issues. So analog prototypes, especially paper prototypes, everyone knows about paper. We've been interacting with them since kindergarten. We can use scissors, we can use pens. It's super quick to start. Whereas if we try to start a digital prototype, we need someone who knows how to code, or at least knows how to use tools that can actually create functioning digital prototypes. And that's not intuitive. That's not something we learn in kindergarten, at least not yet. On the other hand, analog prototypes, and especially paper prototypes, need a lot of labor. So you actually need to cut out the cardboard, you need to write on the paper, you need to write a lot sometimes. And then on top of that, when you're actually testing, you need someone to be the Wizard of Oz. So that's not very scalable, is it? You can't really test a lot of people with that. Every person that you test will need to have someone act as the Wizard of Oz. So either you're going to have a lot of Wizards of Oz testing people in parallel, in which case it's going to cost you a ton of money, because you've just multiplied your Wizard of Oz costs, or You just have the one Wizard of Oz and just a trickle of people lining up to test with that one particular person. Now let's contrast this with what happens in digital prototypes. Well, when we're creating UI elements, for example, we don't have to type everything out and then cut out cardboard. What we can do is just copy and paste a button and then do slight modifications. And typing letters is obviously a lot quicker than writing them. And then copying and pasting something in the digital realm is basically free and instantaneous. If you were to copy and paste in real life, you can't. You basically just need to make a second thing and then say that's a copy. And I guess that's what copying is in real life. It's just a lot easier in the digital realm. It's also a lot easily modifiable. So let's say you wanted to change something in the paper prototype, you'd have to use whiteout. You might even just have to discard the whole thing and then start again. Whereas if you're in the digital realm, all you need to do is just adjust the settings slightly. So maybe you wanted a button to be slightly shorter. You just drag a slider. In real life, I'd like to challenge you to drag the slider of a piece of paper and see if it actually changes. Is there even a slider on a piece of paper? You could cut it, but then you have to cut it. You'd have to find a pair of scissors and then actually do the snipping action and then throw the offcuts into the bin. And if you've made a mistake, you need to start again because you can't undo in real life. And that's just talking about the UI elements. What about the interaction? In a digital prototype, it's just built in. You give someone a copy, they open it, it works. You don't necessarily need a Wizard of Oz. So just by virtue of that, you've basically solved a lot of the scalability problems that we talked about. You've also solved the interference problem because there's no Wizard of Oz to influence or potentially influence the user during testing. And it's also consistent across the board because you just have the one computer program running the interaction. Whereas if you had multiple Wizards of Oz running the tests, that introduces an element of inconsistency. So yeah, essentially the nutshell, as far as I can see, between analog and digital is that analog is a lot quicker to start, which means you can test quicker, but it's not scalable. Whereas digital, it's a lot slower to start. It needs specialist skills, but once it's already started, you can do a lot with it. It's a lot more scalable. So I guess it just really depends on what resources you have available and how much testing data you need or want. Typically, the paper prototype would come up right at the very beginning of the design stage, and then the digital prototype would come in a little bit later. But it's getting more and more common for firms not to have a paper prototype stage at all. So that's just something to be aware of. When I was tech lead at DXC Technology, doing work for hire, consulting work for the AFP, the Navy, or some big oil companies, we found it to just be a lot quicker to just stay all completely digital. Absolutely there is wireframing, absolutely there is sketching, but when it came to actually creating prototypes, we just skipped straight to digital and avoided paper. And it's pretty much the same thing with the immersive design, the immersive tech team over at PVCE here at UNSW. The paper prototyping practice seems to be a lot more prevalent in bigger companies where there are more employees. Although DXC Technology is supposed to be the biggest IT consulting firm in the world, and UNSW isn't very small either, but the teams I was referring to probably would have been less than 10 people, so not very big. So yes, there are pros and cons to going analog or digital prototypes, especially at the early stages of a project. And obviously I'm a digital advocate. I'll openly admit that's a bias that I have. But if you can make analog work for you, then I'm not going to stop you. That's whatever makes it quicker. The key thing here really is to get to that user testing and validate your design. Alright, we're coming up to 30 minutes, so I'll just say see you in class.